come in as we move on. So it's my pleasure to introduce Shamsnaz Virani. Shams comes from WPI, where she's an assistant teaching professor.
Nice to see you.
She received her PhD in Industrial and Systems Engineering from the University of Alabama. Prior to WPI, she was worked with Penn State University and the University of Texas at El Paso. She has developed several teaching educational components in the field of systems engineering. She's also serves as an organizing member, committee member of the INCOSE and the ASCE SCD Academic Forum. She's also founding member of the Empowering Women as Leaders in Systems Engineering, EWLCE, and at INCOSE. She's a member of International Council of Systems Engineering in INCOSE, American Society of Engineering Education, and Institute for Industrial and Systems Engineering. So she does systems engineering, clearly. Her lecture is on moving policies from documents to models, a VA case study. Thank you very much for joining. Please turn off your cell phones. Exits are here and there. And for the students, please, the sign-up sheet is up here, so please sign up at the end of the talk. So thank you very much for being here.
Thank you. And thank you so much for coming. While I was planning this seminar, I thought of various different things to talk about, since I have had 3 institutions of systems engineering and 3 places developing their systems engineering and research program. But I wanted to talk about what is current. So this is what I'm doing like right now. I have 2 students who are there in the lab modeling. So I thought we'd just talk about this. So the agenda today kind of goes from why model policy, and I think it was very fit with the IASE institution of focusing more on model-based systems engineering. So I thought that might be a good topic to do. And why systems engineering should care. I mean, who cares? Policies, that's not our department. You know, that's some abstract entity that develops policies, and we just use it. So, and then case studies, some future research, and other activities. So let's dive into it, shall we? So, why model? And I think this case has been made. Who all are here who are systems engineers, right? Or in systems engineering, yeah. So in systems engineering, we have kind of done this several times where, okay, why should we model? Why do we care? We want to reduce ambiguity, vagueness, duplicity, omissions, inappropriateness, and of course, we do want to increase clarity, simplicity, understanding, and communication. And I think that case has been made over and over and over again. And the fact is, picture does convey more than words, and natural language does lend itself to be interpreted in different ways. And as the workforce is becoming global, and as the technologies are getting more complex, it is even more important to have clear communication, understanding, and simplicity. And natural language can get misinterpreted. Well, not that models cannot, but to a certain extent. So why model policy? Again, same things, increase clarity, simplicity, understanding, communication. Another thing is that we do live here. We live in this complex systems world where we are building system of systems, we are building different technologies that work across different domains, we are building interfaces. So we are living in this world. But what's happening is there are a lot of regulations, standards that we have to confer to, which do trickle down from policy. And what happens is, if there is some gap, some major gap in the policy that hasn't been addressed, it sort of finds its way here. And we say, okay, we built the right system, but why isn't it working? And sometimes it's not really the way you build the systems. You verified it, okay, but that validation loop is what's kind of sometimes missing. So this is where I think systems engineers do get affected by policies. Another reason why you would want is because the new ISO IEC 5288 standard does involve business mission analysis process, which does have business process models. Stakeholder needs, well, this is a huge chunk of what systems engineers do, but also knowledge management process. So it is the systems engineering, and I think even the INCOSI new handbook talks about knowledge management and business process management quite a bit, because it does affect directly how systems operate and how they can be more effective. And that's the reason systems engineers should care about policy and what's happening, how it is trickling it down to systems engineering. So this is something, so the VA came to me last year, last summer, coming with this big issue of they're thinking about modeling policy, and they have different ways in which you can model policy. You can have system dynamics, you can have discrete event simulation, you can have lots of different things. So they were trying to look at different mechanisms of modeling policy and which would be the most effective in identifying gaps. And so we started looking at those, at that policy and the at the policy, something like, systems engineers typically get something that nobody else wants to do. And this was one of those projects which went around, and it came to me, and I'm like, well, let's try it. Let's give me a little bit of funding. Let's try doing this. I have never done this, and I don't know anything in the VA domain. And let's try it. I know, but I do know I'm very good at object-oriented design. I have a very good background. I have done some research in modeling, and let's see if this works. So we didn't have a process in which we thought that, okay, this is step 1, step 2, step 3 of modeling policy. And I didn't even have a sense of the domain. So we started with getting some domain knowledge. And what this is a hypothesized, proposed methodology that one can incorporate if one wants to model policy. So first thing would be the policy selection. Now that's key, and the decision that needs to be made is what parameters are you looking at? Do you want to identify the gaps in the policy, or do you want to just model the policy, or do you want to have a clear representation of all the interfaces? So that discussion needs to be happen first. What policy parameters are you looking at? And you have to, and I think every organization does policy different. So before my experience with the VA policy, my only other experience was faculty handbook as a policy statement. And faculty handbook are written by faculty and are very clear. So other than the UConn, the UConn faculty handbook is a big web page and was really very difficult to understand.
I didn't know that we had one.
No. There is a whole collection of web pages. So you go from one web page to another web page, and I have never seen such a huge document. Typically, it's like a PDF that you download and you go through. Okay, what are the rules and regulations? But
we have Rajiv to tell us.
That's all. Yeah, that's always good. And that's exactly what happens in corporations. That you have one person who's very familiar with the policy, and they and it's their interpretation of the policy, and that's how it trickles down. So and the documents can be huge. So you have to define the constraints and define parameters on what you're looking at. Then comes the defining the key team members. So how many modelers do you have? How many subject matter experts do you have? How many champions do you have? Who are your domain experts? So that team needs to be clear. So that's what is in the policy section. Another thing which is very important is you need a policy subject matter expert, and this is somebody who is involved in writing the policy or has let's say a say on what can go and what cannot go in the policy. In my case, it was somebody from the geriatric and extended care. So he was the director of the geriatric and extended care of the VA, the whole VA domain, and that really helped because then he could push to the DC central office to make the changes in the policy. So what we had is an old policy that was dying, and the new policy that somebody had already worked a lot and developed. So we had somebody who was writing the policy, and we had somebody who was pushing the change in policy. So that those two became the key members for us to verify our model against. And then we had the modelers and the VA, the VERC people, so the Veterans Engineering Resource Center. Then you got to decide the modeling strategy. Now, some policies are lend itself to automation. So if you're looking at kind of like the way I would describe is the way to get paid for the expense sheet reports. Those things lend itself to automation, where you just go through signature, 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 and approve. Some of them. What happened? Okay. So it should be around here. Yeah.
Or you just keep moving the cursor a little bit.
Okay. So some of things are automation, some of them are manual. We use the strategy of going very manual. We would build a model, review it, then build a model, review it, very iterative, very manual. And what I mean by manual again is our models were built only for explanation and communication. They were not executable models. We really didn't go into that zone of making it totally executable because our policy didn't lend itself to do that. But I think the next policy we might, and then we went iterative as opposed to big bang. But you can kind of go either iterative or big bang, and then selection of modeling language. SysML is great for explanation, but it is not great for other things like execution. So you can kind of you should decide which modeling language that would be. And then comes the modeling checking, where either you do several model reviews. So that's important. You have to do some model reviews with your team members and your team members and your subject matter expert, and you'll get interesting reactions, especially from the folks who are not systems engineers. And they are seeing, so in my case, it was a doctor and a business manager. So it was interesting that they got the diagrams, which is good, and they liked it. And then they would ask questions that would help us build better models. Another key thing is having an unbiased representation. So you have a policy. So our policy was on community nursing home handbook for the VA system. And that's a 24-page document. Now, along with that, there is a whole system of CNH. There are several CNH that the VA contracts with, and they are all across the country, and that's a whole different system. That's the system. This is the policy, and our model was of that policy and not of the system. So we have to keep on reminding. So if my team members would say, well, no, not really, this is not how it is done. It's like, yeah, maybe this is not how it is done, but this is how it is written in the policy. So trying to be unbiased, having an unbiased representation of policy becomes a huge challenge, especially if you are, especially when it is a system and which is already established, and you are just trying to model the policy to identify the gaps that are there. See, that's why I think defining the parameters up ahead becomes very essential, because you're not trying to make a better system. And as systems engineers, we want to build, we want to make better systems, but you're not trying to do that. You're trying to capture the gaps that are there in the policy. So you're more of a test engineer. So you're a test systems engineer. So I think that's what I'm trying to do, to tell my students also who are modeling, that don't try to fix the system. You're not trying to fix the system. You're a test engineer trying to capture all the gaps in the system. And then I think this is more of a hypothetical concept model, that you have a model and a policy that are connected to each other, and the evidence then recommends policy change, as opposed to just doing policy because it's old, because it's done, because of several other political reasons. You base it on evidence, and the evidence then recommends a change in policy, and as the policy changes, now this is very hypothetical that as the policy is being changed, the model also changes, or as the model changes, the policy changes. And that way we have a clear representation of the policy, which is now a living document, organically growing and evolving as the population demands change. So let's now dwell deep into the case study. So here is like the full view of what we ended up accomplishing is we modeled the entire CNH 1143.2 policy. Initially, this is what I'm calling an editorial review, where we just looked at, initially I just started reading, and in my naive environment, I thought, oh, policy documents, it will be like requirements document. And I'll do some requirements diagramming, and that will be it. It shouldn't be so very difficult. How can policies be so vague? And as I started reading it as a requirements document, I started identifying lots of vague language, lots of no-call returns. So you would have, okay, update this document, and then there would be, okay, so what? Nothing, no other event afterwards. Is that an end event? So there was a lot of no-call returns, a lot of undefined terms. So they would use things like director, vision director, VA director, and it was never clearly defined who was who. Then a lot of redundancy. So there are like 5 goals on just one thing, and repeated over and over again. So we identified about 49 of those. 27 got resolved. So since we were working with somebody who was updating the policy, we did change 27. We identified 3 major gaps in the modeling, and I'll show you that. And then, so once we finished the editorial review of the policy and made those changes, then we started gathering evidence. Now, in past, VA had tried to gather evidence on policy gaps, and they had like general questions like, okay, do you agree with the goals of the policy? Do you agree with the way the process is written? The way do you identify with the roles and responsibilities in the policies? And these sort of open-ended questions resulted in open-ended answers, which are all over the place. So we had to think of what would be the clear way in which we could hone in on the specific gaps and get usable information or analyzable information that we can then make recommendations. And so we decided to go with the FMEA questionnaire. I think we had 50 people, and I'll show you the results and recommendations. So, okay, so this was the first kind of diagram that we developed, and I go between calling it diagrams and models because this was plainly built for explanation and communication. So in the first couple of paragraphs, this was how they had laid out the whole CNH policy, with identifying what's the role of the VHA, what's the role of the facility, what's the role of the geriatric and extended care program, the Medicare and Medicaid, the community nursing homes, and sort of identified most of the relationships. But there was nowhere in the first few paragraphs the eligible veteran. So when I showed this diagram the first time to my team members, which were the geriatric extended care and the person writing the policy, they just looked at this and they were like, oh, there is no eligible veteran there. Why isn't that? Why is that the case? And I said, well, because it's not written in the document. You don't define it. So then they added the eligible veteran, and we got it all set up in the first few paragraphs. Then this was more on the roles and responsibilities section. So then we started modeling roles and responsibilities, and we used the block definition diagram because there were a lot of operations, and there were some properties that each of the members in the policy had. So we started with the block definition diagram with And then this was an interesting case. So the CNH case manager, so I read through the policy, and in the staffing paragraph towards the end of the policy, I see CNH case manager with sort of roles and responsibility, who is missing from the roles and responsibilities section. Now, editorial review didn't catch it, but modeling the structure of the policy did catch it. Another same thing with the vision director responsibilities, where in the CNH coordinator responsibility, where it's like, okay, the CNH coordinator shall do this, this, and this, and then he should communicate with the vision director, and the vision director shall do this and this and this. So, well, but you have to define vision director as an important role in the policy, which wasn't, again, not captured while writing policies. So those were the three major things that we found while modeling. And this was another thing. So then they had whole goals. So they had about 7 to 8 goals, which were sort of derived from each other. And then there were these two interesting things. So this one was these were redundant goals of implementation of training review and training staff. So those were connected. But this was another interesting thing. This was, again, found in the back of the policy, hospice respite. This is hospice respite and transportation. And I asked the person who was the business manager who was writing the policies, like, why do you have hospice respite and transportation? Because in those paragraphs, the language was also very different. So you could clearly see that all the language here was very different than the language here. And the answer was, it's the law. The lawyers want that to be there. It's some part of the law that they have to provide hospice, transportation, and respite, and it has to be there. So then we kind of debated where it should go, because then I asked her, why don't you put it in the goals section when it is one of the important goals? And she's like, no, I can't put it in the goals section. This is where it has to be, and this is how the language has to be. They have to be very individual paragraphs. And so that then became here, and it stays as, I wouldn't call it as it's a major fault or a failure or a gap. It's just different at this point. So after finishing these, we kind of identified 3 major gaps. Then we collected data on severity, occurrence, and ease of change between the old policy and the new. So this was kind of, we got the policy at the right time. We had the old policy, which was already in place. And when we would call people at VA, and I think VA people are very dedicated field workers who are working with veterans day in and day out. And when they are not happy about the policy, they let you know. And they really let you know. So everybody would go into this, what I called a unstructured rant about the policy, that this is not working, this is not working, this is not working, this is not working, this is not working. And in that whole unstructured rant, it was difficult to then pick pieces up that you can analyze. So FMEA did help us kind of get them to talk about these things, the severity, occurrence, and ease of change. And since we already had the old policy, we had people who were very familiar with the old policy, and then we had 25 people who were looking at the new policy for the first time, and their interpretation of how the gaps have been addressed. So we could see some of the changes that they've already made, and then some of the changes that need to be made. And then, of course, this helped us capture the gap and build evidence-based recommendations. So these were some of the major failures that we identified, this was one of their major goals. And then we had 5 other gaps nested under this whole thing: planning and provision of long-term care, implementation and training, and then again all of these nested under that construct, and these 5 in the CNH oversight and quality control. So if we had not gone through the modeling process, it was very difficult to then identify all of these as clearly as we could. After collecting data, so this is our the final view of collected data. We called up a lot of people. We identified what were the main gaps, and then we started calculating the RPN, which was just the severity times frequency times ease of change. Now, when you do hardware-related failure modes and effects analysis, it's very easy. So you just say, okay, can you detect the fault? Whereas in this case, I had to change it from detection to ease of change because everybody could detect the fault, but so I didn't get any variability in detection, but there was a lot of variability in how easy it was to change. So we kind of changed the FMEA language a little bit, and of course the whole survey was constructed with not saying that these are failures, but saying that these are gaps. So gaps was a good word to use when we are talking about policy. So between the old policy and new, no available CNH with specialty needed, and long and difficult process to add new CNH to the VA program was a couple of the most important, and they remain the most important in the old and in the new. And then,
how come your RPN increased with the new policy?
It can because they still had not made effort in changing the language for the no available CNH with specialty care, because I think that's one of the major problems that they are facing, and they still don't have a very good process, because we talk to a lot of contractors, and most of the contracting training is about how to buy a missile or how to buy a tank. But when it comes to health services and getting nursing homes and things like that on the contracting for VA, they don't have a clear process defined. And this handbook is supposed to define it, and it doesn't really do a good job defining that too. So that was, so in both and so it's getting even more. And another thing is, as the population is aging, the ventilator care is becoming more and more needed, but not there. Within there, I think they have some laws like it has to be 40-mile radius or 50-mile radius. And so it's becoming very, very difficult. And there was a previous study also that did research on the same thing. And they also identified, what they identified is the VA system-wide market has high quality community nursing homes, and VA, the ones that are contracted with VA, have a low quality. So, and one of the reasons is these two to a certain extent. Then we also looked at the training, and even in the training, no training, outdated or low quality, no clear signs seem to be the highest RPMs. This one, it was a little bit all over the place, and I think one of the reasons might be because this was the last question on the questionnaire, and that sometimes does happen, that when you are interviewing human subjects, you have to be careful at that you randomize the order of the questions too, and this might be one of those cases, but we got results like all over the place, so we couldn't really make any strong recommendation on this this section of the survey. So we did the basic risk analysis of having severity against likelihood laid out, and if you just did the severity, and so we threw out the ease of change and just looked at severity and likelihood. In this case, we had the C3 and C5 here, whereas C3 and C5 were really clearly addressed in the new policy. So the top is the old policy and the down is the new policy. Whereas B1 went from here to here, which I think might be part of the reason, might be because the new policy does identify roles and responsibilities, and also one of the major goals is training, but there is nothing associated with training in the rest of the document. So it was pretty clear. So the good news was the C3, C5 were addressed, whereas the gaps still remaining were B1, which was the no training, which was in the red zone. A3, again, long and difficult process to add a new community nursing home. No available community nursing home with specialty needed, and then I think a lot of them associated with training. So with that, we could make strong recommendation of adding a section on training in the policy, so having clearly defined training expectations for all the roles was clearly stated, and that actually got changed. Consider provider agreements or change in the initial review process. So when we were interviewing a lot of people, there was a time where we could do a provider agreement, and that was a quicker process than contracting. And because the way the provider agreements were written is it's sort of like a buffet. So you just order the whole services that the community nursing room have, and you just pay them that total buffet price. Whereas the VA contracting was more like for every care that the veteran needed, you had to go and apply for another reimbursement. So that was another strong recommendation. The third was maybe you need to research as the aging population and as the specialty needed is what kind of specialty care is needed, and maybe that can be added, or that change can be made in the system, so the policy can be ramped up to that level. So this was the PowerPoint that the geriatric and extended care medical doctor did give to the Washington DC folks who were trying to, I think that's where the policy is right now. I think they took all our changes, they made the changes, and now it is in DC getting reviewed by them on having some systemic changes here. So what did this whole experiment really do is it did definitely have the impact to understand dependencies across multiple sections in the policy, helped us analyze the document policy, understand the operational aspects of the policy, edit the policy, identify major gaps, develop systems view, identify major actors and their roles in the policy. Future research. So this was funded research for last summer, and this year we have now 5 policies that we are looking at, and we finished modeling 2 of them. And one of the major things that we are identifying as future research is building a structured language, having a machine readable structured language, so we can automate some part of modeling, then modeling like right from scratch. Building algorithms, some sort of algorithms that will give us some predictions of fitness of the policy. And also, since this time we are looking at 5, we are looking at an enterprise-wide view of the policy, which policy, because there are a lot of external dependencies. So you'll have something like, okay, this process shall use this handbook for this thing. So those external dependencies have to be visualized in some ways. So those are the 3 things that we are now focusing more on. So does anybody have any questions on the policy and the VA case study? Yeah.
How do you actually model that?
Model policy?
So what is the model?
The model is more like, the way I would see it is, it's a pictorial representation of the natural language. So we start by identifying the structural and the behavioral elements. So I think in the way these VA policies have been written, you have the roles and responsibilities section. And typically they will have some paragraphs that are same across this, so paragraph headings that are same across. So we look at those headings and we start with the roles and responsibilities section, and we do the block definition diagrams of those. And then we look at the behavioral aspects, like one policy right now just has requirements, a lot of requirements for the waiver process, requirements for contracting, requirements for inventory management. And so we are looking into the behavioral models like sequence diagram, activity diagram, and allocating and then tracing the roles and responsibilities. So in responsibility, they will have, CNH coordinator is responsible for the waiver process, and then you have a whole waiver process defined. So then we identify use cases of how these actors are now associated in what part of the waiver process.
So you use basically SysML here, or?
Yeah, I'm just using SysML. So last year I used the visual paradigm as a tool. This year, the VA, I think, made a decision to buy Spark systems, so we are using Spark systems.
So what are you doing with the natural language things? Are you basically extracting your model from the text?
Right now, we are doing it manually.
Yeah.
Eventually, we do want to build a template or a language specific that the VA can then use to actually model or extract models. So the students are right now working at modeling, but one of their back jobs is to sort of develop that structured natural language that can be extracted. Because
basically
I think
some keywords.
Tagging using some sort of supervisory sets and unsupervised learning sets. We haven't really. We are still struggling with it.
So is the VA's intent to get rid of the text and the model with the policy?
I think they're testing the waters. I think they are new to systems engineering, and they are testing it and seeing if there is any value. And if there is value, then they might continue.
So, right now you're just using it to validate the text, right?
Yeah. Right now we are not making any policy. Well, yeah.
But you could have the model and the natural language translator. You could SysML, if requirements at least. You can generate a requirements document.
Yes.
Which in this case would be a policy document from the model.
From the model. But you could also see how this.
I've seen things where people have used Petri nets, at least in the Navy. Some guys.
DoD does a very good job, and DoD has actually. I have talked to DoD people, and they actually have a very specific way in which they do policy.
Architectures and everything.
Architecture and even the policy. They have a very specific.
Alex Levis does a lot of this stuff. George Mason.
Needs to see my face.
Yeah. So DoD, even any basic policy in DoD is very well. The process is very well structured, but in VA it is the policy building process is also not very well structured, and they have documents all over the place. There is a lot of redundancies between documents. There is different interpretations of the same processes all over so whichever prison you are looking at, it's a little bit different.
I thought when you said VA, maybe you're solving the problems that they found last year.
This funding did come out of that GAO report. Okay. It did come out of that report that they needed to make some changes, and the Veterans Engineering Resource Center is using, has funded lots of academics all across to sort of help resolve some of the major issues that came out of GAO report. And they, while I was modeling and doing all this failure modes and effects analysis, the business manager actually did send me parts of the GAO report that she had to look at to write the new policy. So it is part of that mess up. But right now, I think right now they are looking at. So we were looking at this in that process.
One question I had was going back to your second or third chart. Mm-hmm. You talked about selection of a modeling language.
Yeah.
So for policy analysis, SysML is just a good use of that, but people use causal loop diagrams or system dynamics.
Yes.
So did you look at that?
No.
Why did you choose SysML over?
Because I don't know system dynamics. I don't. You could, and a lot of people do. So I've been talking to people. So a lot of people who do use system dynamics very successfully do the game and then build it, and that does give a lot of good data too. But it is.
I think that whole thing is junk in my view, because they use all the stupid names like stocks and flows and all
Flows,
that stuff. Typical MIT crap.
Two MIT people here. The third one also.
Yeah. So I understand that you build a model and then you do an FMEA with the model, which makes perfect sense.
Yeah.
What's the activity of validating that the model is actually a correct interpretation of the original text?
Okay, so that was just showing it to the team members who were writing the policy and interested in the new version. We didn't go validate it across the whole population. So in my case, we just did.
Is there, is there a way to do like some form of sensitivity analysis or something to see how the model responds to various scenarios, and then present that to see if that's in agreement with the intent of the policy, as opposed to?
You could do it. I mean, you could do it. It's just the problem is as you go. So, it is not an engineering world. It is people who are who have a business degree or a Bachelor of Arts degree or nurses and doctors. So you have to. I would clean up a lot of the model, and I would make it as simplistic as I can, and go in with a small explanation of what the model would be, and then have folks like it, not like it, or do an sensitivity analysis that way. But I would clean it up quite a bit and make it very simple, make it like just flow chart sort of easy. Yes.
Yeah, I think you're starting to get at my question. So, what are some of the ways that you can present things to people who are not like systems engineers or engineers that think that analytically? Are you guys experimenting or thinking about how you can present that kind of data to business and other types of people, help them feedback and test the fitness of a policy per se?
We are not. We are not thinking in that direction yet. But you can do it. The way I would do it is I would go back to simple flowcharts or simple ways in which I could represent it, where it does represent some complexity, but it's not, all the data is not there. And that way, or I would run through scenarios. I think that's what I would do. I would run through, okay, the waiver process. So this is a scenario for the waiver process, and do a whole simulation of that scenario. And then that would be more explanatory as opposed to just doing the...
Do you have more charts? Or?
Yeah, I've got more, yeah. So that's what I would do, is do scenario to scenario. And I think even with requirements, that I think seems to work better if you have scenarios and small prototypes. Then the whole requirements document, the 2,000-page document, that I don't know what happens, and everybody complains, and you get stuck in that. Any other questions? So other activities that I've been doing over the years, I think George did talk about those, so let me talk a little bit about my teaching. I've taught at 3 institutions now for systems engineering. I've also taught online, on-campus, on-site courses. In fact, I do come to Hartford at UTC to teach requirements engineering. They have a nice tech ed center. It's quite cool facility. Some things I've done in online capstone now. I used to be, the students, you would be there, you would have teams of students, and they would do the project that they would like, and it was just another dummy project. So I threw that out, and I started getting a real-world customer. So I've had Visiting Nurse Association of New England, CEO, and the COO, and both of them, we identified 3 or 4 projects that the students can do, and since the students are online, they don't have to drive, and they have a commitment of an hour a week to talk to my students, and so now we do real-world projects online, and I think the project quality has gone way up high, and the students' engagement in the capstone projects have gone really high. So I really like doing that, and even with my requirements engineering, I've changed the whole course around where I sort of now have the students think of how they would want to write requirements 10 years from now. Do they want to still do the way everybody has been doing? And what is that futuristic goal going to be? And we focus more on those techniques than what is already there. And so we use the old ones that are good, and then we think about and we do develop some new ways of doing requirements. I think we focus more on prototyping and simulations and scenarios as opposed to the right language of writing requirements and the grammar of writing requirements.
What's your average class size? What?
This was 12, but it's 12 to 15. I think WPI caps it at 15.
And you offer it as a cohort or as independent courses, or?
I think in UTC it is independent, because there are some students who are not with the students, whereas in electric board, when we were coming to electric board, it was cohort based. Research, the latest have been the policy modeling.
So that SE fundamentals, does it go into SysML there or no?
I do have
what is your course content? You have typical 14 lectures?
So the SE fundamentals is 14 lectures because it is on campus.
Right.
Whereas the requirements engineering, since it's on site, it's 10 weeks.
Okay. So what are the typical topics in SE fundamentals? Because Abad has been teaching that course here. So,
I use the Fabrici book, the Blanchard Fabrici book. Other folks use the Kasiokov book. I never liked the Kasiokov, so I just use Blanchard. But I'm coming to a point where I don't want to use any of the textbooks because it's expensive for the students. And since I teach this on campus, we don't have a systems engineering on-campus program, so we get mostly robotics students, and they really don't want to buy textbook or whatever. So we are coming to a point where SE fundamentals might not have a textbook. But common topics initially are just, the first is the overview. Second would be the concept development, needs analysis, problems analysis. Then we would go into stakeholder analysis, and we spend a lot of time in needs and concept development and stakeholder analysis. And then we go into the requirements. So we go with the preliminary review, the design, detailed design. So we do 2 stages, and then I wrap it up around that time. But I do want to change that course too. I just haven't had a chance to really think more in terms of robotics and think more in terms of the millennial population and change it to attract those students as opposed to traditional systems.
So those are actually 2 different courses.
Systems SE fundamentals and requirements.
Those are both masters?
Yes, all of them masters. I haven't taught undergrad. I used to teach undergrad.
So WPI has a master's in robotics?
Yeah, we have undergrad also in robotics.
Undergrad, and you had to know there was a master's also.
Yeah, and a lot of students do BSMS. So systems engineering becomes part of that BSMS. I see it here. Okay. All right, so...
last question. And you introduced SysML in the beginning, and how do you incorporate SysML in course?
Okay, so the way I have been doing it is I have one class where I introduce model-based systems engineering, and then I have them do an exercise in class, and then I give them a homework on it, and they are supposed to develop 2 or 3 deliverables of their project in SysML. So that's sort of, and they become my recruiting tool also for my summer research. That's how I got two of my students. They are masters in robotics, but they're working for me in summer. And I've already told them, I don't know whether this will get you a job in robotics, but sure enough, it will give you some systems engineering experience.
So would you be interested in doing a model-based systems engineering course, that maybe as a second course?
I've taught model-based systems engineering in UT El Paso and at Penn State.
Okay.
It's sort of.
And what is wrong with it? what is wrong with it, or what kind of experience you had with that?
Okay, so you tread a very thin line between making it tool-centric or concept-centric. And it ends up being the type of students you get. So if it was a professional development environment like the WPI environment, I would go tool-centric, although they don't want me to, but it would be more tool-centric because that's what the students want to know is how to use this tool and how to implement systems engineering models. So I would give them more experience on modeling.
There is a SysML course in WPI, right?
Yes.
Yes,
that's an online, But I don't teach that one. I haven't taught that at WPI, but I've taught it. So in Penn State, when I taught it, I was focused more on the model and the tool and the modeling. Whereas at UT El Paso, we had PhD students and all over the students. So then we did dwell into a lot of object-oriented design, lots of design patterns. And Fred still believes that after Sandy's MBSc course, we should have another course which was more on object-oriented design and object-oriented design quality, which is my dissertation, is in software, in object-oriented design quality, and identifying those quality characters. So it's sort of like you are not making pretty pictures, but you're making models that are useful, and where is that fitness of use?
Is there a need for example, SysML I still think is more like a diagrams. How about teaching something with SysML and maybe like a Simulink together, so that you can actually do the simulations of things?
Well, I think in WPI, well, they don't do SysML, but there is a course, or used to be the course from one of the professors who left, was on model-based design.
Okay.
And in that, you go from Markov chains, the discrete event simulation, to all the way to stochastics and everything else that is model-based in the hardware-software domain. So you do like one on this, one on this, one on this, one on this. So you have all these modeling languages, modeling techniques. So you don't get into the depth of anything, but you do get a sense.
I think we already have that kind of stuff in embedded systems.
Yeah.
Right? You guys do all those things.
Yeah, I mean,
two lectures or 3 lectures
Yeah.
are dedicated to that.
So I'm more interested in like a complex systems, not just necessarily embedded or anything. How do we go about teaching them from the requirements all the way to model-based design? Is there a course like that could be taught using your capstone type projects, basically project-based?
You can, but you have to force them to, they do need some prereqs on Simulink and SysML, and then you tie it all together in a project. So but if the students are not, if this is the first time they are looking at SysML and the first time they are looking at Simulink, it's just getting them that learning curve and getting them up to par will be, I don't know, I think about 10 weeks of the 14-week program is just getting them up, and then in the next 2 weeks, it gets a little bit difficult. And most of
usually at the undergrad level, our guys know SysML. I mean the Simulink.
Typically, but in Masters of Systems Engineering program, you get folks from all over and who are in work environment, and they are like more professional students with life and work, and so you have to sort of think about what is that 2 things that they can just use and take it to work. Sort of. So a couple of other papers that I have worked on was a human reference architecture and using reusable architectural tactics. This was looking at the Software Engineering Institute's reusable architectural tactics that they have developed in the software engineering world, and seeing if we can implement it in the systems engineering world. And as I said, software quality was my dissertation area, object-oriented design quality. And I've done some work with engineering education, where I developed a 4-year engineering curriculum in a high school in El Paso, and we've implemented that from the systems perspective, and that has really resulted in good retention and recruitment of the students to go into engineering disciplines. So it's a little bit a wide net when it comes to research. So that ends the presentation. if any of the students have any questions. It's very quiet out there.
First, let's thank our speaker. Do you have any questions? We asked most of our questions during the presentation. So
Most of the students want writing questions, not block diagrams.
Anything else? I mean, any other questions?
I have a student question. If you go and say I'm a systems engineer, is it better than saying I'm a chemical, electrical, or whatsoever?
Well, it is an
Getting high.
interesting, the way I like to say it's an interesting conversation starter. It's a conversation piece because 90% of the folks don't know who a systems engineer is. So they'll ask, okay, what is it? And so then you can say how great you are, sort of looking at end-to-end systems and things like that. So cradle to grave, that's been my way of thinking about systems engineer, that it's a conversation starter. I know as soon as I say, so sometimes when I don't want to make a conversation, I try to say, oh, I teach engineering. And then I dread, don't ask me what engineering.
Interestingly, UTAS has an initiative now to define what is a systems engineer.
Yeah.
In the sense that they know they want to hire them, but they don't know what they are.
Yeah.
It's very interesting because there's no systems engineering curriculum like by default. So
No, there are things.
there are a
There
few.
is the basic.
You go to MPS, George Mason, Virginia.
No, but in terms of a standard curriculum like mechanical,
Right.
if
Yeah.
there is a mechanical engineer, you know what subject he or she has studied.
Yeah.
Systems engineering doesn't have that, so you're right. But there is this initiative within INCOSI which is called GRACE,
Basic, yeah.
Graduate Studies Standard
Graduate
Curriculum.
reference
Something.
systems engineering curriculum.
So there is that effort to standardize.
So did you
Also-
go to that, what is that, Edinburgh? You guys went there?
It's next month.
Oh,
We're
next
done.
Are you going?
No, I'm not because several reasons. But in academic forums that I've been part of, we are trying to do just that: identify systems engineering curriculum and making sure that we collect all the new things that people are doing, so we have a good repository of topics and how to teach those topics in systems engineering. We are also talking to ABIT, and I think ABIT is doing a whole change in their whatever their criteria, and we are really INCOSI folks are really lobbying ABIT to introduce some SE related language.
So they remember there used to be that IE Institute of
Institute of Industrial
So now
Engineers.
they've changed it to IISE,
Yeah.
Institute of Industrial and
Systems
Systems
engineering.
Engineering,
Okay.
and they are working with ABET to certify or whatever they do.
See, one of the things that, so I consider myself a systems engineering guy, but we came from more control, communication, and all that. One of the things that we don't like all these things is it's basically blocks, right? We like to have some math underneath. So that's why I think it's important to be able to link.
But I think that's a different definition of what systems engineering is, right?
Yeah,
Yeah, but they
link whatever you have. This is one of the
when
requirements
you
thing.
talk formal methods,
Right.
that is the math underneath that. So the graphs, all the blocks that you see,
Right.
they should be executable.
Executable, that's what I mean, yeah.
Yeah, so they should be in terms of checking consistency and traceability and all those things. So those tools, SysML is language, but the tools some tools provide those kind of executable capabilities.
So who are the people that do that?
No magic draw, skate.
Yeah.
Yeah, I think we use Magic Draw. Our guys use, but I don't know how to. Yeah.
Yes.
Yeah, and you have to think about it from the way I think about SysML is it's the sister of UML, and the UML was introduced to have some program understanding, so code understanding. So the way I think about SysML is it is a good tool to understand what the system is, because you read requirements and you have these heterogeneous models all over the place. You have CAMCAD, you have some simulations, you have some policies, you have some standards. It's just all over the place, and SysML is more helping to understand what these all things are trying to convey. So it's
And how they link to each other. That's
how
the
they,
most
the
important part.
traceability, and so that I think is the value of SysML, is to have the homogeneous expression of those heterogeneous models.
Yeah, having that and maybe focusing on
Focus,
and how those things get executed in an executable model. I think that
Right. I mean, it's linking the overall architecture to actually the behavior of all those components. And SysML doesn't really talk about behavior.
well, that does have a behavior.
I mean,
They do,
but
they do,
not-
yeah, they have this.
Yeah.
Yeah, it's not like simulation. It's not.
Right.
Yeah, it's not as precise and executable.
Right. It's not like I mean, I'm used to System C as a system modeling language. And that's completely behavioral, right?
Yeah.
Yeah, but so there is this parametrics diagram in
Yeah.
SysML, and you can link the physics-based models to that. Although,
And I think that's what Krishna is asking for, that link between.
so that is not provided by Magic Draw, that's not provided by Scale, or
But I've seen
but that's provided by, I think, Phoenix Integration is a company that provides that capability of linking the two, merging the two together.
yeah, I've seen IBM guys also trying to link Silverlight and SysML.
So, thank you very much for coming. Good news is that you spurred many discussions, and let's thank our speaker one last time.